For this next example, you have already seen on the website the theorem for the area of a regular polygon. And in this example, we're talking about a regular octagon is inscribed in a circle with a radius of 4 units. And we want to find the area of this octagon. Now you can draw the picture with or without the circle. Either way, you'll get the right answer. Just with a radius, we normally would involve that in a circle. So the first thing I'm going to do is add another radius. So now we have radii. And both of them are 4, and what you're going to notice is that we have a triangle. The next thing I'm going to add is the apothem. That apothem is with the right angle. It has to be that way. So this is now our apothem. We now have a right triangle. So that triangle is just a little bit bigger there in the picture. And the apothem is, again, that perpendicular segment. And the side length will be the whole bottom side, the whole base of that triangle. Those are the two things that we're going to need to be able to solve for the area of this octagon. So another thing that we need is a central angle. The central angle will be the entire top angle of the triangle. We're going to take 360 divided by our number of sides, which is 8, and that's going to give us 45 degrees. Now we can talk about our formula. You can use either one, 1/2 a times the perimeter, or 1/2 times the apothem times the number of sides times the side length. For this example, I'm going to use the second equation. So what I'm also going to do is split that triangle. Since it's congruent on both sides, we're going to look at just one part of that triangle. We still have the radius, we still have the apothem. Now we need to look at the bottom side. This is not the entire side length of the octagon, so we're going to call it something different. We're going to call it B. And also, the angle at the top is going to change. Since we only have half of the triangle, we're only going to have half of the angle. So half of 45 is 22.5. Now we're going to solve for the apothem and for the bottom side of the triangle. To do that, we're going to have to go back to our trigonometry. Remember, across from the right angle is our hypotenuse. So in this example, we're going to have to use sine and cosine. I'm going to solve for a first. So for that, we're going to have to use cosine. Cosine of the degree, 22.5, equals the apothem divided by 4. We're going to solve for a, so we're going to multiply by 4 on each side. And we're going to cross out the 4's on the right side. So we're left with 4 times the cosine of 22.5 equals a. Remember, the 4 will not combine with the degree. The degree in a triangle can never change. So once we put that into the calculator, and also remember your calculator needs to be in degree mode, we're going to get 3.7 units. Now we're going to solve for b. So instead of cosine, we now have opposite divided by hypotenuse, which is sine. So sine of 22.5 equals b over 4. Again, we're going to multiply by 4 on both sides and cross out the 4's on the right side. So the bottom of the triangle, the base, is equal to 4 times the sine of 22.5. When we plug that into our calculator, we're going to get 1.53. Now we can go back to the bigger triangle that we had before. We have the apothem at 3.7, and we have part of the side length of the octagon at 1.53. To find the entire side length, all we need to do is multiply by 2. So now the side length of the octagon is 3.06. And now we're ready to use our formula. So 1/2 times the apothem times the number of sides, which is 8 in this case, times the side length. So 1/2 times 3.7 times 8 times 3.06. Plugging that in, we're going to get 45.29 units squared. Notice that I'm still rounding to the hundredths. Even with all the trigonometry that we had before, we're still going to round to the hundredths. And if your answers are just a little bit different than the textbook, that's okay because of how we are rounding.